Okay, the first four warm-up problems are on the board. I apologize for lowering them down 1, 2, 3, 4, but once we're done with problems 1 and 2, as you can see, they don't take that much time. I'm going to erase them so I have more space to do these two problems. Okay, so please pause the video and complete these four problems. Okay, now that you are done pausing and you've completed all four problems, hopefully, let's get on with it. We have a multiplication problem, x plus 11 times x minus 4 equals 0. So I'm going to split these up into two cases, x plus 11 x plus 11 equals 0, or x minus 4 equals 0. I'm going to piece by piece solve for x. So we've got x plus 11 equals 0. I need to undo that plus 11 layer by subtracting both sides by 11. It's one louder, you see. We're going to subtract 11 on both sides. 11 minus 11 is 0. So x equals negative 11. Okay? And on the right side, we've got x minus 4 equals 0. So we're going to undo that minus 4 layer by adding 4 on both sides. I'm going to add 4 to both sides to get negative 4 plus 4 to cancel out to get x isolated. X equals 4. You plug in either one of these two and your solution will get us a zero product. Okay? Moving on to problem number 2, what we didn't get to yesterday is we know that if we have a binomial getting squared and the result is 0, then I don't need to copy it down twice. It's only one solution. So in this case, all I do is just move on and just say, hey, 7x minus 12 equals 0. So now I'm going to solve for x. 7x minus 12 equals 0 means I'm going to undo the outer layer, getting me negative 12 plus 12. And, whoops, I almost fell down. Oof, that could have been bad. So negative 12 plus 12 cancels out and gets me 0. 7x equals 12. We know that 7 is not going to go into 12 as a whole number, so I have no problem with you guys leaving it as an improper fraction. I'm going to divide both sides by 7, getting me, let me get a red so it's vibrant and noticeable, x will equal 12 sevenths. And I would box that. 12 sevenths is the answer. And that's the only one. Hence, that satisfies the solution set. Okay? Now that I'm done with problem number 1 and problem number 2, I'm going to erase them when I get to problem number 3 and number 4, respectively. Okay? Now, well, number 3. 8x plus 21 times negative 6x minus 29 is equal to 0. I'm going to split these up into two cases. So I've got 8x plus 21 equals 0, or negative 6x minus 29 equals 0. Okay, hopefully you guys are done with problem number 2 because I'm going to erase it. The most important thing I want to advise you, do not play hero. Show the work. I've seen way too many people like try to go, oh, it's the answer is 8/21, or 6/29, or 29/6, or one of them, or whatever. Just put a negative in front of there. Show the work. It doesn't take that much time. Okay. So 8x plus 21 equals 0. Minus 21 on both sides to undo the outer layer. And we get 8x equals negative 21. Okay, 8x equals negative 21. And now, I need to undo this by dividing both sides by 8. And I'm left with x equals negative 21 over 8. If you like decimals, I'm not going to look it up right now. I know it goes in there twice with 5 remainder. So 5/8, I'm pretty sure I know what it is. Yep, that was correct. So x can be negative 2.5, negative 2.625. Sorry about that. See, even a guy with a bachelor's degree can make mistakes. Okay, either one of these two are okay. All right, negative 6x minus 29 equals 0. I'm going to undo the outer layer by adding 29 on both sides. And we get negative 6x is equal to 29. So now I'm going to want to divide both sides of the equation by negative 6. Now, 6 can go in to 24 and 6 can go into 30. So if I plug in 29 divided by negative 6, I'm going to get a decimal. A positive divided by a negative will be a negative. So I can leave this as negative 29 sixths. Let me just make that a little bit of space so you know it's negative. Or if you really, really insist on a decimal, I'm pretty sure it repeats. Yep, it repeats. So that'd be x equals negative 4.83, but notice in the calculator it repeats the 3, negative 4.8333333333. So when it repeats, we normally put a hat on the repeating part of the decimal. So either one of these two, fraction or decimal, please put one of them. Same thing over here, but I need to see both distinct solutions. Okay, number 4. If we're afraid of this, we can just put a 1 in front of the variable. So I'm left with negative 1n plus 20 equals 0, or negative 1n minus 3 equals 0. So I'm going to undo the layer on the outside by doing minus 20 on both sides, leaving me with negative 1n is equal to negative 20. Then I'm going to divide both sides by negative 1, getting me negative 20 divided by negative 1, which is just positive 20. That's only one solution. Let's go to the other side. So we've got negative 1n minus 3 equals 0. I'm going to undo the outer layer by adding 3 to both sides. If I add 3 to both sides, that gets me negative 1n equals positive 3. Divide both sides by negative 1. And you will get positive 1n is equal to 3 over negative 1. 3 divided by negative 1 becomes negative 3. So either one of these two solutions will satisfy the requirement to make that statement true. Okay. Moving on to the next part of the unit, Just make sure. Okay. So just to go over some key vocabulary. By the way, the zero product principle does come back. I'm just going to add an extra step to it. But before I go on to that, I want to make sure you guys understand the vocabulary as well as the pre-algebra requirement to do the next unit. It's going to be called factoring. Okay, so let's take a simple multiplication problem. Let's go with, what did I put down in the type part? 6 times, let's go over a simple multiplication problem, like 6 times 4 equals 24. So, like was said in the zero product principle, if one of the factors is equal to 0, then the product is equal to 0. So, just to clarify, if you have a multiplication problem, the 6 and the 4 are known as factors. So 6 is a factor and 4 is a factor. But the answer to a multiplication problem is called the product. So the question I want to ask is, if you've taken some sort of algebra in middle school, you might have been told that you need to factor the polynomial. So the question I want to ask is, well, what does it mean to factor? I hate to do a grammar lesson, but what does it mean to factor? Okay, so a factor, as in a noun, is one of the numbers in a multiplication problem that results in a product. The product is the answer to a multiplication problem. So to factor means, well, to use it as a verb. So to factor, right? We have a long-term goal. Okay, the long-term goal to factor a polynomial make that lowercase. To factor a polynomial means to break up a product into its factors. In other words, we want it to be a multiplication problem. Okay? The goal is to make it into a multiplication problem because it serves a higher purpose when you go into Algebra 2 and Pre-Calc and Calc. Okay? Now, before we go on to that, you might have learned something called prime factorization. In other words, you want to break a whole number down into its prime factors. So for instance, example number 1. Let's go with 24, like seen up here. So 24, I'm going to do this in 2 ways, by the way. So 24 can be broken down to its prime factors. You make it to a multiplication problem until you cannot factor it down even more. Factor until you see the primes. So I'm going to go with what is seen up here. I can break down 24 into 6 times 4. So 6 times 4 can be broken down even further because 6 is a composite number. 6 is not prime. I'm going to break this down into 2 times 3. So 6 is broken down into 2 times 3. I'm going to break down 4 because 4 is not 4 is a composite number. I'm going to break this down into 2 times 2. Luckily, now in the next step, we've got 2 times 3 times 2 times 2, 2's prime, 3's prime, 2's prime, and 2's prime. So this whole thing is broken down into its primes. Make that a little bit clearer. But let's say you picked another set of factors, that's okay. You could have done 3 times 8. And just drop the cap, I'll get it. 3 times 8, well, 3 is prime, so I'm going to leave that be. But I'm going to break down 8 into, let's go with 4 times 2. 3 is still prime, so leave that alone. 4 is not prime, so I'm going to break that down, and 2 is prime. So the only thing I need to break down is the 4. 3 times 2 times 2 times 2. So either way we get the same result. 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. Okay? See if you can do the next 2 problems by breaking it down into its prime factors. Let's go with 50 and 90. Actually, no, I'm going to put that on the right. 50 and 90. Pause the video to do these problems independently. Okay. So I'm going to break this down. You could have picked 2 times 25 or 5 times 10. My personal preference, at least for me, is to get towards the middle. So if I go too wide, like 1 time, well, first off, 1 times 50 doesn't really help me. I could technically break any whole number down into a bunch of ones being multiplied and itself. But 2 times 25 will be helpful, but I personally like 5 times 10. So 5 times 10. 5 is a prime number, so I'm going to let that be. 10 is not. So specifically, 10 can be broken down into 2 times 5. 5 is prime, 2 is prime, 5 is prime, so I've got these completely factored out. Let's go to 90. Again, I could have had a variety of factors. I could have done 2 and 45, 3 and 30, 5 and 18, 6 and 15. But personally, let's go with the ones in the middle, because the ones in the middle tend to break up a lot faster. So I'm going to go with 9 times 10. So I'm going to break this up now. Is 9 prime or composite? Well, it's composite because I can break this down into 3 times 3. 10 is composite. It can be broken down into 2 times 5. So 3 times 3 times 2 times 5 is how you break 90 down to its prime factors. Now, what you learned next after that is to figure out the greatest common factor. So I'm going to erase this part here. What does it mean to factor? Because we will get to it by the end of the period. Okay. So the greatest common factor of 2 whole numbers is going to be the long-term goal that we care about for polynomials. So the greatest common factor, or commonly abbreviated as the GCF, is there's 2 ways we could do it. One, with a lot of practice, we just figure out what's the biggest number I could divide from both of them. Or if that confuses you, you can always use the GCF. I mean, you can always use the prime factorization and circle the ones in common and multiply them. So let me show this one really quick. So find the greatest common factor of 6 and 10. So I want to figure out what's the biggest number I can divide out of 6 and 10. In other words, I'm going to factor it out. So if I have 6 and I have 10, I can break up 6 into, well, 2 times 3. I can break up 10 into 2 times 5. Okay? Are there any factors in common? So now that's broken down to the primes. 2 is the only factor they have in common besides 1, but the greatest common factor of 6 and 10 is 2. So that means that I can divide 6 and 10 by 2 and still get whole numbers. But if I have a more complicated case, like 18 and 24, sorry about that. Okay, so let's say we know the answer, but I just want to make sure that we all understand we're all on the same page as to how we get there. 18 can be broken down into, let's go with 6 times 3. Well, 6 times 3 and 24 can be broken up. Let's go with 6 times 4. So I'm going to break this up now 6 times 3 is 3 times 2, and 3 cannot be broken down because it's prime. I'm smiling because I gave the answer. I can break down 6 and 4 yet again into 2 times 3, and that 4 can be broken down into 2 times 2. It's all broken up into primes. I just want to clarify so that nobody gets confused. We're going to circle the ones that we have in common. The right side has a 2, and the left side has a 2. The right side has a 3, and the left side has a 3. Other than that, I don't see anything else that they have in common. Even though there are multiple 2s and 3s, we need to have the same amount. 1, 2, and 1, 3 in this Venn diagram where they have in common. So the greatest common factor of 18 and 24 is 2 times 3, or 6. So the biggest number I can divide out of 18 and 24 is 6. Okay? See if you guys can do the next two problems independently. Okay? Okay. See if you guys can figure out what the greatest common factor of 30 and 60 is, and the greatest common factor of 75 and 125. Make up 60 a little bit neater. Okay. Okay. So what I like to do is break this up. 30, let's go with 10 times 3. Okay. Can I break up 10? Yep, I can. So 10 can be broken up into 2 times 5, and 3 cannot be broken down, so it's 2 times 5 times 3. Now let's break up 60. 60 can be broken up. Let's go a little bit of variety. I'm going to go with 4 times 15. I can break up 4 into 2 times 2. And I can break up 15 into 3 times 5. I just wanted to do something different just in case everyone was like, wait, did I do this right? You can always get the same primes when you factor them out. Doesn't matter if you did 2 and 30 and then broke it down from there, 3 and 20, 4 and 15, 5 and 12, you're going to get the same result. So now let's look at the ones that they have in common. So the greatest common factor can be achieved by looking at what they have in common. Do we have a 2 on either side? Yes, we do. Do we have a 5 on either side? Yes, we do. Do we have a 3 on each side? Yes, we do. Notice that the GCF of 30 and 60 is 30, because I can divide 30 by 30 and get 1. I can divide 60 by 30 and still get 2. The biggest number I can divide out of both of them and still get a whole number. So 2 times 5 is 10, times 3 is 30. The GCF of 30 and 60 is 30. Let's take a look at 75. So 75 and 125. I'm going to break both of them up. Well, 75, let's just say I pick 5 and 15. You guys might have picked 25 and 3. That's totally fine. Just wanted to be different. 5 times 15. Well, can I break down 5? No. But can I break down 15? Yes. I'm going to break down 15 into 5 times 3. And can I break this problem down even more? 5, 5, 3, both factored into primes. 125, I know for a fact that the best way I can use this is with quarters. 25 times 5, right? 25 cents, 5 quarters is $1.25. So now I'm going to break this up. 25 can be broken down into 5 times 5. Yeah, you can leave it like that. 5 times 5 times 5. I don't want to confuse you guys with the dots, but sorry about that. Just want to make sure we understand that parentheses next to each other also means multiplication, just like dots. So now I'm going to look from left to right. Do we have factors in common? Do we have a 5 in common? Yep, we do. 5 and 5. Do we have another 5 in common? Yep, we do. Do we have a 3 in common? We do not. And that 5, there's 3 5s on the right side, there's 2 5s on the left side. So the smallest factor we can factor out is 5 times 5. 5 times 5, let me get a better red marker. 5 times 5 is 25. So the GCF is 25. Okay. Make sure we're looking at the clock. Okay. So I just want to give a sneak preview for the next unit. Why am I going over this? Because we're going to be using this information to factor out a polynomial. Practice and practice and practice with the greatest common factor, and this won't be so bad. Okay, so we're going to do 2 problems, and then we're going to kick off Monday with this lesson. So factor the polynomial. So let's say I've got something like this, 2x plus 6. Just get a little, I call these jumping jacks kind of problems because they're like little warm-ups for the bigger picture. So 2x and 6. Well, I look from left to right. Whole numbers. What's the GCF of 2 and 6? Well, it's 2. And do we have another variable in common? 2x has an x, but 6 is just a constant. It does not have a variable. So the GCF of 2x and 6 is just 2. The goal is to do the reverse distributive property. And we're going to check our work with the distributive property. So now we've got 2 factored out of 2x and 2 factored out of 6. So now 2 times what is 2x? So 2 times x is 2x. 2 times what is 6? Doesn't this feel like Nick Jr.? Doesn't this feel like Dora the Explorer? It's like, now I know what it feels like to literally ask a question and there's nobody in the audience to answer. 2 times what is 6? Positive 3. Swipe or no swiping. So that's how you completely factor it out. And we can check our work by literally distributing it. So if I go 2 times x plus 3, I'm going to distribute the 2, right, and get 2x. And then 2 times positive 3 is going to be positive 6. The goal is to be flexible. The goal is to be able to go from expanded form into factored form. And we can check our work with the distributive property. See if you can do the next problem on your own, and then I will see you guys on Monday. It's actually 3n minus 15. The GCF of 3n and 15. Well, we look numbers. Is there something we can take out of 3 and 15? Yeah, the GCF of 3 and 15 is 3. I'm going to reverse distributive property, aka factor the polynomial. So now I've got 3 times what is 3n? 3 times n is 3n. And now I've got 3 times what is negative 15. Good! 3 times negative 5 is negative 15. You can check your work. So I'm going to erase this part down below. If I FOIL this, if I distribute this out, I'm going to get 3 times n, which is 3n. 3 times negative 5 is also negative 15. So this whole thing checks out. So let me just erase that, and I can put the box factored out. We're going to do more of this on Monday.